Hi, so today we're going to talk more about net forces in our little net forces boot camp here. We had talked about them before whenever we were doing our labs, but I wanted to have some more formal problems on this so you could figure out both picture problems and word problems having to do with net forces. So let's start off with me. If I am lifting a kettlebell, what are some things that are true about the forces that are at work? Well, first of all, if I am in the process of lifting this upward, that means a change in movement. So the forces are unbalanced. It also means if this is getting moved upward, that the force of gravity is not as big as the force of me pulling upward. So that lifting force is higher, the pulling force. Also means that I'm ripped because it's a big kettlebell. So these are two different forces in opposite directions that we're looking at, the force of gravity pulling downward and that lifting force of me pulling upward. So what do you do when you have forces in opposite directions? Well, what you're going to do is subtract the two numbers. The difference of those two numbers is the amount of the net force, and that force is going to go in the direction of the bigger number. So if you have 50 newtons being pulled upward and 10 newtons being pulled downward, you would subtract the two and find that the overall net force is 40 newtons, and that is an upward force. So what do you do if those forces are in the same direction? Well, here's our example for that one. I am flying on a bird and the wind is pushing us in the correct direction, in the direction we are flying. So what does that mean? Well, we have two forces going in the same direction and nothing equally balanced pushing in the opposite direction. So these are unbalanced forces. Once again, it's going to be a change in movement. That extra push of the wind is going to help the bird move faster. And it's also going to mean that the forces are moving to the right because that's the only way that we have forces in this scenario. So same numbers as last time. If you have 50 newtons going to the right from the bird flying and the wind is pushing another 10 newtons, how would you find the overall net force? Well, whenever they are in the same direction, you are going to add them together, and the direction of the overall net force will be in the same direction as the arrows you're looking at. So we would have 50 plus 10, and that would be 60 newtons, and both the arrows are pointing to the right, so it's 60 newtons to the right. So now it's time for you to solve some problems, and we will go over them to see how you are doing. Okay, so the child has a force of friction of 20 newtons to the right. The dog is pulling to the left with a force of 70 newtons. So I want you to figure out what is the total net force in this situation, and also what is the direction of the force. I'll give you a second now. All right, so using our rules from before, we have a force to the right and a force to the left, which means opposite directions. So we are going to subtract, and then it will go in the direction of the larger force. So let's look at our answers here. So that means that there will be 70 minus 20 newtons, which is 50 newtons. And since the bigger force is to the left with the dog, it is going to be 50 newtons to the left. Our next problem here, we have two children running in a tackling dummy. We're going to focus on the boy in the blue. Okay, so he runs at the tackling dummy to the left with a force of 30 newtons. The net force in this situation is 30 newtons to the left. What is the force of the tackling dummy? All right, so this one's a little bit different. I want you to think about this for a minute. If you know the force of the boy and the overall net force is the same as the force of the boy, what does that mean about any other forces that are there? Hopefully you're able to figure out that that means that the tackling dummy has a force of 0 newtons. All right, there's nothing opposing his force moving to the left. And so it is the only force. All right, for our next problem, we're going to have a little gravity problem here. So the force of gravity is pulling the kitten down with a force of 24 newtons. What force amount and direction does the receiver need to use to safely catch the kitten? Okay, so the goal is to have enough force to cradle the kitten so it does not continue to fall downward, but not so much force that you fling the kitten back up into the air. All right, so how much force would that receiver need? So the receiver is going to need to use 24 newtons upward because 24 newtons was coming down so that there are balanced forces in order to stop the kitten without flinging it back up into the air because there was too much force, or the kitten continuing to fall because there was not enough force. All right, now it's time for our final problem that we're going to do as a group. So if you're looking at our little superhero who's walking towards us, we're going to look at drawing a force diagram for him. All right, in your force diagram, I want you to put down the two moving forces, what the overall net force is, and if this is a balanced or unbalanced situation. So here's the information I'm going to give you. Our superhero is walking with a force of 15 newtons and has a constant speed and direction. So what would you be able to draw in order to convey that? If it is constant speed and direction, think about what that means for the forces. All right, so let's look at what the answer is. Hopefully I gave you enough think time. Otherwise, pause right now and keep thinking. So what that means is the force of him coming towards us is going to be 15 newtons. He's walking with a force of 15 newtons, but he's not moving anywhere. So the backwards force is also 15 newtons because of the constant speed and direction. Okay, so you need to have an arrow in each direction and have the same amount of force in each direction. The other thing is, if he is moving at a constant speed and direction, that means that the forces have to be balanced. Okay, if you would like to practice more, or if you have time at the end of class and would just like to play along with this website, there is another option for you in the slides. You can go to the final slide and there's a link to the FET simulations, and there are net forces simulators there where you can play tug of war with different sized forces and look at how it affects the balanced and unbalanced forces and also the speed of the situation.